So hello everybody and welcome back to my YouTube channel, and in today's video we will be learning about the important 40 tables for GPAT. So जब हम बात करते हैं GPAT की, it is categorized, the preparation strategy is categorized into two particular topics, major and minor subjects. So when I talk about major, we have pharmaceutics, pharmaceutical chemistry, pharmacognosy, and pharmacology. While in the minor one, we have biochemistry, microbiology, biotechnology, pharmaceutical jurisprudence, clinical and hospital pharmacy, human anatomy and pathophysiology, etc. So, and BBPK, biopharmaceutics and pharmacokinetics. So basically there are certain tables, there are certain topics, कुछ ऐसी frequently asked चीजें हैं जो पक्का पूछी जाती है और आगे भी पूछी जाएगी. मतलब अगर आप हाउ डू यू स्टडी, मतलब अगर आपको ऐसा है कि आपको लास्ट एक मंथ का रिवीजन करना है, सो अगर अपनी यू हैव मेड दीस टेबल्स, definitely your preparation is going to be way more easy. It's going to be like a cakewalk. So firstly, the first one is the different techniques of biotechnology and microbiology. So gram staining से जरूर question पूछता है, like teichoic acid, peptidoglycan layer, the examples of gram positive bacteria, staphylococcus and all, and gram negative, so Vibrio cholerae, Escherichia, Neisseria, Haemophilus influenza and all. Then different types of ingredients used. So we have primary stain, mordant, secondary stain, decolorizer, and how do you differentiate the final color, the observation inference. Then culture media, so different types of McConkey's agar, Savarez dextrose agar. We have different medias, different components, beef extract, peptones, yeast and all. So the role of those particular components in a culture media, different types of culture, primary, secondary, suspension, and other in cell culture. Then techniques like RT-PCR, PCR, because there have been frequent questions from that. ELISA, southern blotting, western blotting, northern blotting. So definitely like not on the procedure, on the particular topic, like what is the role of blocking agent, example of blocking agent in western blotting, electrophoresis, what are the different types of electrophoretic mobility, isoelectric focusing, all those things. So, similarly, for microscopy, different types of microscope, we have dark field, we have phase contrast, we have SEM-TEM scanning electron microscope, transmission electron microscope. So all those things you need to be well much aware about. Then from biochemistry, if I talk about, we have different kinds of pathways. So we have glycolysis, which is Embden-Mayorov pathway. Then we have HMP shunt pathway. Then we have Krebs cycle, citric acid, that is also called as TCA, tricarboxylic acid. Then we have gluconeogenesis, which is formation of glucose from non-carbohydrate precursors. Glycogenesis, formation of glycogen from glucose. Glycogenolysis, formation of glucose from glycogen. Then we have PP, pentose phosphate pathway. So different locations. There's a glycolysis in cytoplasm, while Krebs is in mitochondrial matrix. Oxidative phosphorylation is in F1 or F0 particles, and basically mostly in inner mitochondrial space. Similarly, we have different kinds of locations. So you need to know the locations and the key enzymes like rate limiting enzymes or reversible steps, if any. So over here we have pyruvate kinase, hexokinase, glucokinase, and phosphoglucokinase. Here we have aconitase, isocitrate dehydrogenase, citrate synthetase, and the purpose, like how many ATPs are formed, or are there any phosphorylation steps, or is there anything special about it, like like oxidative phosphorylation we have and all those things. So what is it converting? How one NADH2 it produces 3 ADP molecules, one FADH2 produces 2 ADP molecules. Then we have again on techniques. So again, I've mentioned few other. So if you're preparing for NIPER or other competitive examination, cluster related techniques is very important. So sequencing techniques, CRISPR-Cas9, it is a gene editing technique as well. So for gene therapy and personalized medicine, CRISPR-Cas9 technique is very, PR is palindromic repeats. So this is very, very important. Then we have DNA sequencing. So DNA sequencing may we have different methods. We have Edman's reagent, which is phenyl isothiocyanate. We have Sanger reagent. Then we have 2,4 dinitrobenzene, 1,4 dinitrobenzene. Right? These are all reagent techniques. Edman, Sanger's and all. So this has been asked dansyl chloride, dansyl reagent. है diaminosulfonyl. So there are a lot of questions that have been asked from this particular topic. So you need to know the principle, like PCR. There are three steps: denaturation, renaturation, denaturation, annealing, and polymerization or extension. So at what temperature? So this is at 95, this is at 55, this is at 72. What is stack polymerase, thermus, aquaticus, all those things. What are the role of oligonucleotides? What is RNA primer? What is DNA ligase, RNA primase? So all those things. Then flow cytometry. This is a very good technique for cell sorting and cell counting. So cell flow cytometry is where there are quadrant divisions and all, in which you come to know about the cell viability, right? So that is important from this particular table. Then we have a table on different techniques. So again, like we have different techniques: transformation, transfiction, transduction, conjugation, electroporation, microinjection, right? All those things, biolistics. So there is a TI plasmid, Agrobacterium tumefaciens plasmid. So there is crown gall disease associated with this particular plasmids. So vectors, plasmids, cosmids, phagmids, yeast artificial chromosome, bacterial artificial chromosomes. All these things you need to know while you are preparing for GPAT, because these tables are going to help you. If you study theory, लास्ट में क्या होता है, आप आखिरी आखिरी में क्या चाहिए, आप अगर लिखा होगा बहुत ज्यादा कलर्ड पेन्स यूज नहीं किए तो इट्स वेरी डिफिकल्ट कि इतनी सारी बुक्स कैसे खत्म करें. टैब्यूलर फॉर्म में होगा, फ्लो चार्ट्स में होगा, धड़ाधड़ उड़ जाएगा. You will not even have much of stress. So vectors that I was telling you, also vector capacity, how many kilo base pairs that it can accommodate. Then the different examples. So we have plasmid of Bolivar and Rodriguez, PBR 322. We have lambda phage. So there are different cos sites. And cosmid, there are cos sites. So cosmid is the hybrid of bacteriophage and plasmid. Then bacteriophages are viruses that infect bacteria. So you need to know the characteristics. So plasmid is circular, self-replicating, autonomous, right? It's autonomically replicating and self-replicating, circular. So these are important things that you need to know. Moving on, again there are certain enzymes and the applications. So you need to know the different enzymes, and also certain enzymes are used as biomarkers. Alkaline phosphatase, acid phosphatase, like it is used in prostate cancer. Then we have amylase, lipase in pancreatic diseases. So there are different enzymes that act as a biomarker, and also certain cofactors. So like cytochrome oxidase ka cofactor is copper metal. Then pyruvate kinase ka cofactor is phosphate, potassium ions. Then similarly, selenium is a glutathione peroxidase ka marker. So like this, then for dinitrogenase, we have nitrogen as a biomarker, which is a metal. So different metals that are being biomarkers for particular, or cofactors, you can say, for particular disease. Then again, enzymes ka thermos aquaticus, as I already mentioned. Then we have reverse transcriptase. So there are different transposons as well. So we need to know about the jumping gene phenomena, DNA transposons, RNA transposons, retrospons, right? So retrovirus, then restriction endonuclease, the types of restriction endonuclease, type 1, 2, 3, and the different restriction sites, how far away they cut, at how many kilo base pairs or how many base pairs they cut the particular cleavage, where's the cleavage. So there are different ends, palindromic ends, sticky ends, sharp ends, blunt ends, staggered ends. वो पता होना चाहिए. DNA ligase, so the role of ligase is to join, right? All these things are very then protease. So protease inhibitors we also do add while Western blotting, because we need to protease is the enzyme that converts proteins into peptones and proteases. So we proteins into peptones, and so proteases needs to be inhibited during Western blotting, because we don't want our protein to degrade. We want our protein to be expressed, right? So this is very important. Then we have certain microorganisms and the applications. And also you can study a table of microorganisms and from which the antibiotic is obtained. So Escherichia coli, there are different types of other Streptomyces venezuelae for chloramphenicol, erythrias for erythromycin, Griseus. Then we have a lot of different microorganisms: Micrococcus luteus, Streptomyces orchidaceus, Streptomyces canamyceticus. You name a particular bacteria and you get a particular antibiotic from them. So here we have application like Saccharomyces cerevisiae is baker's yeast. It is used in fermentation. Bacillus thuringiensis is a biopesticide. And there are nitrogen fixation cycles. So we have different bacteria: Pseudomonas, denitrificans, nitrosomonas, Azotobacter aceti. There are different Azotobacter. So there are different bacteria. So Bt toxin, that is Bt cotton. We would have heard about Bt cotton. Bacillus thuringiensis mediated cotton. So all these things are very essential, these tables. Then for particular concepts, I already mentioned that transfection. So fection में Fe है, E stands for eukaryotes. Similarly, transduction is for virus, VD. Transduction is for virus, and transformation is for bacteria. So electroporation is another technique for bacterial transformation. Then there is gene knockout. So knock in, knock out, and knock down. There are different techniques. So you use siRNA, silencing RNA, miRNA, microRNAs, and all. So they are the the role of these particular and allies. Now, from jurisprudence point of view, we have drug different acts. What area does it cover and what is its importance? So, like Drug and Cosmetic Act, 1940. Then there are rules in 1945. Pharmacy Act, 1948. Drug and Magic Remedies Act, 1954. Medical and Toilet Preparation Act, 1955. Patents Act, 1970. NTPS Act, 1985. So there are very important acts. Then 1919 we have Poison Act, Dangerous Drug Act in 1930. Then 1971 maybe we have Medical Termination of Pregnancy. Right, so we have different acts. Then in 2013 we have DPCO that came into existence. Now from 1995 after there was another revision in 2013. What are the areas? So you need to know about misbranded, adulterated, and spurious. Misbranded is what? Anything that is colored, coated, polished. Adulterated is some putrid, filthy substances added. By spurious is it is of another company but stored under another company or marketed under another company. And if it's not labeled in a prescribed manner, it's again a misbranded drug because it's not labeled appropriately. Then Constitution of Pharmacy Council of India. So there are State Pharmacy Council, Joint State Pharmacy Council. The members ex officio nominated, elected. Right. Then for Patents Act, you have different terminologies: patent, copyright, trademark, trade secret, geographical indication. So their duration, like copyright for how many years, 60 years or so, trademark for 10 years, patent for 20 years. So you need to know all those things, but it's very, very essential. Then what is bonded and non-bonded laboratory, for which excise duty is being paid. Then what? How for NTPS? What is the different first what is the first conviction, second conviction, and if you perform any subsequent particular punishments? How many thousand? How many lakh rupees? How many years of jail? All those things. Then what is bhang, ganja, charas, flowering, fruiting tops, which is 0.1% cocaine, 0.2% morphine. What is the concentration? All those things. So this is very essential, like knowing about the acts, like medical termination of pregnancy. So how many doctors are required, registered medical practitioners if it's below 20, 12 weeks. If it's between 12 to 20, how many practitioners are required? If it's after 20, it's not allowed only for abortion. So you need to know the acts, the purpose, and the year. Very essential. Prevention of PFA, Prevention of Food and Adulteration Act 1954. DPCO, so you need to know the formula for ceiling price, cost price, and all. Now, next you need to know from regulatory affairs, and so normally also certain regulatory bodies. So IPC Ghaziabad, then IVRI, Indian Veterinary Research Institute, Izzat Nagar, Central Drug Research Institute, Central Drug Laboratory, Kolkata, Central Research Institute, Kasoli, and all. So you need to know PCI, where is the head office, headquarters, like Geneva, Switzerland, maybe have different headquarters. So WHO and all, where are the different headquarters and all. You need to know different organizational bodies. It's very, very essential, like IVRI. Also, then there is Pune Virology Institute in Pune. Like, so you need to know about that as well. It's very essential of different authorities like NPPA sets the NLEM, National List of Essential Medicines. So they set a maximum read MRP and all, base price, cost price, ceiling price, all those things. Moving on, we have different regulatory bodies for different countries. So, and from this, I'll be marking that's more important. So, from UK, we have MHRA, Medicine and Healthcare Product Regulatory Agency. From US, we have FDA, CDSCO for India, Australia के लिए Therapeutic Goods Administration, Europe के लिए European Medicines Agency. Now, be careful. For European, it is European Medicines Agency, and for Sweden, this is Medical Products Agency. So be very, very careful when you see over here. Medical Products Agency, and then it is medicine. Medical in Sweden and medicine in Europe. Japan ke MHLW, Ministry of Health and Family Welfare, Labor Welfare, and also for PMDA, there's another this thing for regulatory body. Then more important regulatory body you need to know is about the Sri Lanka SPC, State Pharmaceutical Corporation, NAFDAC for Nigeria, and Visa for Brazil. These are all important regulatory bodies that you must know. Moving on, the types of receptors for pharmacology. There are different types of receptors: G protein, iron link, iron gated, enzyme link, intracellular, that is nuclear. What is a heterotrimeric, so pentameric? What are the different subunits like GS, GI, GO, GQ? The examples. So what other and mechanisms? So like adenyl cyclase, cyclic MP, GTP, CGMP, phospholipase, CIP3 DAG pathway, which is for calcium Sarca release. Then we have examples are very, very important. Examples are asked very often. So make sure that you are aware about all of this. That are showing you. Next, we have isomerism. So from chemistry point of view, structural, functional, tautomer, metamer. Then there are different kinds of isomers like configurational, conformational, atropoisomerism, biosterism, geometrical, optical, cis-trans, EZ, syn-anti, dextro-levo, erythrio-trio. So many, stereoisomerism. So different examples like this particular isomerism belongs to which particular category. You need to know that very well because it's asked very commonly and very frequently. So you need to know the examples, like if they give you a particular this thing structure, suppose this is a structure. So you need to know that will you apply cis trans here or EZ? Obviously you will apply cis trans because although there are four functional groups out of which two are common. But here on the other hand, if I add another group, suppose if I add F and then I add over here something OH. Four different functional groups. You cannot apply cis trans. You have to apply EZ. So this is important. Then from pharmaceutical calculation part. So from pharmaceutical calculation part, basically you need to know about the different types of dosage calculations like percent strength, alligation method, dilution, extraction yield, suppository में what is displacement value. So for those calculation you have Young, Dilling, Fried, Clark, those kind of formulas. So that is very important that you are well versed with those formulas because they are asked very commonly in examinations. Alligation may they give you particular concentration like here, suppose 60% of alcohol from 40 and 90, there are two parts and all they give you like this, so then you have to subtract 60 30 40 60 20, so there are 50 parts. So like these you have to solve particular questions. Then from molarity, normality, all those terminologies from physical pharmacy you need to know. Now moving ahead, when I talk about the different HAP systems, so HAP may we have skeletal, muscular, nervous, cardiovascular, respiratory, digestive, endocrine, renal, which is urinary, reproductive. We need to know the different components like skeletal system, so axial, appendicular, muscular system, smooth muscle, cardiac muscle, skeletal muscle. What is the difference? Nervous system, CNS, PNS, what are the components? Brain, spinal cord. Now brain also has different components, forebrain, midbrain, hindbrain. Again, it has so many different components further. Cardiovascular, heart, blood vessels, arteries, vein, difference between them. Respiratory system, pharynx, larynx, trachea, bronchi, bronchioles. Digestive system, esophagus up to the anus, cecum. Endocrine system, the different glands, pituitary, endocrine, exocrine, parathyroid, pineal, thymus. Different glands, urinary system, kidney, urethra, urinary bladder, GFR, all those normal values. Even for respiratory, lung volume. So we have tidal volume, inspiratory reserve volume, expiratory reserve volume, viral capacity. You need to know that. Then from flow of fluids, if I talk about, so different flows of fluids are there. There are different types of manometers that are involved. Like we have different kinds of simple, inclined, differential. Reynolds number, maybe we have different kinds of Reynolds number. That's very important to know about Reynolds number because they ask very frequently streamline flow, laminar flow, turbulent flow. Bernoulli's theorem for what is the definition, what is the Thum energy, what is potential energy, what is kinetic energy. Then different kinds of instruments or equipments, venturimeter, rotameter, pipette tube. These are asked very frequently. Size reduction may we have comminution. So we have different laws, Kick's law, Bond's law, Rettinger's law, different equipments, fluid energy mill, pin mill, ball mill, hammer mill, roller mill, cutter mill. So they are principle, impact and attrition, and the advantage, disadvantage. Which one is for soft and sticky, which one is for abrasive and friable materials. For size separation, we have sieve shaker, cyclone separator, sedimentation tank, etc. And for heat transfer, we have Fourier's law, Stephen Boltzmann law, Kirchhoff's law. So we have conduction, convection, radiation. Then from distillation, we have simple, differential, fractional, molecular, short path evaporative, and different distillation techniques. What is distillate? What are the advantages? Like which distillation? What is a dry distillation? What is destructive distillation? You need to know the simple, the principle, and the application. That is mostly asked. Nothing beyond that. Principle and application. From centrifugation and filtration, we have SATs, asbestos filter, filter candles, and centrifugation devices. We have perforated, non-perforated, super devices. From mixers, we have different solid mixing, liquid mixing, sodium solid mixing. So what is Silverson's emulsifier? From different kinds of other mixers, Z-arm mixers, planetary mixers, what is double cone blender, ribbon blender, all those things. From dryers, we have tray dryer, drum dryer, vacuum dryer. So you need to know what is EMC, equilibrium moisture content, what is FMC, free moisture content, what is CMC, critical moisture content. Moving on, there are certain parameters for quality assurance. This is a subject where we all live, but sometimes there are questions. So, what is specificity? What is accuracy? Difference between accuracy and precision. So, precision ensures reproducibility and repeatability. The intermediate precision. There are different kinds of precision as well. So, then we have linearity, where a linear regression curve is plotted. Sensitivity, then we have LOD, local limit of detection, limit of quantification, where signal to noise ratio of 3:1 and 10:1 is to be maintained. Then repeatability, the robustness, ruggedness, when we talk about United States pharmacopoeia, these are important parameters. Then from pharmaceutical analysis, in analysis basically we have different techniques. Titration may we have redox, acid base, complexometry, redox, acid base, complexometry. In redox, we have again different kinds of them. We have precipitation also. Redox may we have iodometry, iodimetry, bromatometry, permanganometry, stereometry, dichrometry, all those things. Neutralization, acid-base reaction is also very important. NMR spectroscopy, H1 NMR, C13 NMR, spectrometry, maybe have UV visible IR, NMR, mass, all this. We need to know the detectors, the sampling techniques, the graph. Make a table. Detector, source, sample, the wavelength range, 200 to 400 nanometers for UV visible, and so range. If you make a comparative table of all 656 spectroscopy, fluorimetry and all is also there. So Jablonski's diagram, what is it? And all those Stokes law, what is Stokes shift, anti-Stokes shift and all. So you can make that as well. So these kind of particular things will make your life more simpler and more easier. Now when we talk about electrophoresis, so we have gel electrophoresis, capillary electrophoresis, then we have isoelectric focusing and all electrophoresis techniques. So you need to know agarose based gel electrophoresis, that is very important. Then SDS page, polyacrylamide gel electrophoresis. Because chromatography may we have HPLC, GC, TLC adsorption to the principle, the column used, and the types of chromatographic techniques, may what is Van Deemter's equation, and all those are asked very frequently. Similarly, Hooke's law, coupling constant, all these Pascal's triangle, and Joule solution, Beer-Lambert's law, Weiss's law, Miller indices from X-ray diffraction technique. These all are being asked. So you need to be Woodward-Fisher rule from UV spectroscopy. So I hope that you all will be studying this particularly. Moving on, you need to know from for hospital pharmacy what is the composition of constitution of pharmacy therapeutic committee, who's the secretary, who's the chairman. You need to know about the floor stock system, charged, non-charged, then unit dose dispensing system. You need to know about centralized unit dose, CUDDS, and DCUDDS, decentralized, there is satellite pharmacy and all. So that is very important. Then different management techniques, so ABC, FSN, EOQ, economic order quantity, fast moving, slow moving, non moving, always better control, VED, vital, essential, desirable. So you need to know about this. Then how do you calculate these values? What is reorder level? What is buffer stock? Then from pharmaceutics, you need to have a comparative analysis. What is tablet, capsule, parenteral, aerosol? So evaluation test, methodology, excipients, equipments, miscellaneous. So make sure that you are aware about all of this. So tablets say hardness, resolution, disintegration, friability, weight variation, uniformity of content. The specifications, how much time is dissolving, what is noise Whitney, what is Fick's law, what is Hickson Cravel, Crew-Brood law and all. So you need to know, be well versed with that. Then different dry, chilsonator, roller compactor, slugging, dry granulation, wet granulation, direct compression, excipients, a binder, glidant, diluent, disintegrant, then miscellaneous for what is tablet defects, mottling, chipping, lamination, orange peel effect, roughness. Capsules may be different types of gelatin, type A, type B, glycerogelatin ratio, rotosort, rotofill and all. Opacifiers, bloom strength, iron content, viscosity, moisture content for capsules, parenterals, may pyrogenicity, so like 1% ethylene blue we use, sham test and all, we have the testing lal, limilism, lysate, aseptic area class 100,000, 10,000, 1 lakh, vehicles like cryoprotectants, lab protectants, preservatives, solubilizers, reformulation parameters, aerosol maybe a particle size, all the equipment. This is the table is very important. Particle size distribution, identification, moisture content, flash point, flame projection rule, vapor pressure, foam stability, spray pattern, etc. इस पे काफी बार प्रश्न पूछे जाते हैं. And also the filling techniques like vacuum filling, pressure filling, एंड ऑल, इस पे काफी बार प्रश्न आए हैं, तो मेक श्योर दैट आप पढ़ के जाए इसके बारे में अच्छे से। देन अबाउट डिफरेंट स्केड्यूल्स फ्रॉम जुरिस्प्रूडेंस, सो आपके पास अलग अलग स्केड्यूल पे जरूर प्रश्न पूछे जाएंगे, स्केड्यूल ए बी सी डी ई एफ जी एच आई जे। सो आपको सारे स्केड्यूल्स पता होने चाहिए बहुत अच्छे से, क्योंकि you should not be making mistakes much, so make sure that you know about this। एंड आपको बहुत ईजी है, तो मैंने यहाँ पे आपको एक एक वर्ड में लाइक the statements are too big from the according to the drug and cosmetic act, are you going to remember two big statements? No, you need to know the difference from A application, B fees, C biological, C parental, C1 non-parental biological, D exemption from import, E poisonous, F vaccine sera, G medical supervision, H prescription, H1 with additional regulation, J ailments that cannot cure, M1, M2, M3. So all these in detail, P life period, P1 pack size, R mechanical contraceptives, S standards for cosmetics, X narcotic and all. So you need to know the tables well. Then this is the same table from biochemistry that I mentioned, key enzymes, purpose, location, pathways. Similarly, certain hormones, you need to know the hormone changes, because in HAP pathophysiology, there are questions on hormones, thyroid, T3, T4, TCT, pancreatic hormones, insulin, glucagon, somatostatin, pancreatic polypeptide, ACTH, FSH, LH, progesterone, testosterone, estrogen, ADH, vasopressin, prolactin, relaxin, inhibin. You need to know the rules and how they are regulated, feedback mechanisms, the inhibitors of those agents, like insulin, maybe we have oral hypoglycemic agents. Similarly, thyroid, antithyroid drugs, carbimazole, propylthiouracil, and all. So, somatostatin analogs, octreotide, and all related to growth hormone. ADH में भी है vasopressin, lesmipressin, telmipressin, and all, lysipressin. Parathyroid में levothyroxine, liothyroxine, and all. Then different synthesis you need to know. So when I talk about synthesis, so this like cholesterol synthesis. So HMG-CoA reductase is the main rate limiting enzyme. Cytoplasm meet occurs. Different steps. Ketogenesis में beta oxidation. So there's de novo fatty acid synthesis. And there's beta oxidation of fatty acid. What is carnitine shuttle? What is fast fatty acid synthesis? You know the how many ATP molecules are being generated or being released. And for like palmitic acid is formed. What is saturated and saturated fatty acids. So the components, function and examples like DNA, RNA, protein, transcription, translation, ये सब आपको पता होना चाहिए अच्छे से. Now next, vitamins. So a table on vitamins is very essential. So thiamine, riboflavin, vitamins, ring, deficiency, function. Vitamins, ring, deficiency, function. इतना काफी, आपको ये बहुत अच्छे से पढ़ लेना है. Different vitamins, different rings, different functions, the deficiency. So pellagra, beriberi, pernicious anemia, megaloblastic anemia, scurvy, Wernicke-Korsakoff syndrome, osteomalacia, rickets. These are all kinds of deficiency disease that occur. Then when I talk about the particular topics, so carbohydrate, we have in biochemistry, we have carbohydrate, protein, lipids. इससे पक्का there are questions on biochemical tests, Molish, Benedict, Balfour, Selevinov, Felling, Tolin. Protein से bioretin, hydrin, Hopkin, Cole, Sagakuchi, Polys, Philin, Milan, Folincio, Caltio. From lipids, we have Lieberman, Burkhardt, Salkovsky. So from you have certain tests. Then classification, aldoses, ketosis, homopolysaccharide, homopolysaccharide, heteropolysaccharide, monosaccharide, disaccharide, protein में simple lipids, compound, glycoproteins, simple compound, complex, conjugated, derived, glycoprotein, lipoprotein, nucleoprotein, phosphoprotein, chromoprotein, all those things. You need to know the example, what is sphingomyelinase and all, right? What is cerebrosidase? So carbohydrates हो, protein हो, उसके classification को करना काफी जरूरी है. What is hollow enzyme, apoenzyme, different types of enzyme, oxidoreductase, transferase, hydrolase, isomerase, lyase. In सबके particular examples are IUB, International Union of Biochemistry, has given this classification. Then what are the different genetic disease? So we have Tay-Sachs, hexosaminidase, sphingomyelinase, so many different kind of McCardley, Fope, Corey, Anderson, and a Her, Tarui, alkaptonuria, so many different genetic diseases that occur due to SCID, severe combined immunodeficiency. So we need to know the different enzymes involved in these particular diseases. Similarly, for pharmacognosy, always make tables: medicinal plant, biological source, and then phytoconstituent, then uses. So like aloe vera, so it is a C glycoside. And you can take one more column of tests: bond tagger, modified bond tagger, the family, the active constituent, aloin, barbelloin, isobarbelloin, beta barbelloin. So this is a very good way of studying particular pharmacognosy. Then for extraction, you can make one table: that maceration, percolation, digestion, decoction, infusion, microbiology, countercurrent. है ना? So the different applications. And if there is an equipment specific, like Craig's apparatus is one of the equipment used in counter current. So this also you can make. Then for evaluation, we need to add different kinds of evaluation parameters, morphological characteristics we have, like lycopodium spore material, stomatal number, stomatal index, vein islet number, vein termination number. काफी जरूरी है उसको पढ़ना. Similarly, biopharmaceutics and pharmacology की basics से what is loading dose, maintenance dose, what are the different types of transporter systems पता होना चाहिए, and different types of terminologies, bioavailability, half-life, therapeutic index, agonist, partial agonist, full agonist, inverse agonist. Examples जैसे inverse agonist का beta carbolin है, for partial agonist is buprenorphine, buspirone, which is serotonin receptor and mu receptor agonist and all. So what is the role of them? What are the different example techniques you need to know? Half life and all. What is plasma half life? What is elimination half life? When I talk about name reactions, there are types of reactions. Obviously, substitution, addition, deletion, elimination. What are the examples? What are they converting into? Because they might ask you to convert. They might give a particular reaction. They might be showing that what is it used for converting and all. Mechanism, what is an electrophile, nucleophile, free radical, SN1, SN2, E1, E2. It's very, very important to know that mechanisms. Drug class. So medicinal chemistry say you need to know the class of the drug, the key synthetic steps. So what are the different, like lidocaine, maybe we have xylidine ring for preparation of lidocaine. For beta-lactam antibiotics, we have beta-lactam ring, xylate, hyaluronidine ring and all. So all those things you need to know the particular heterocyclic ring in a particular drug. It's very, very essential. Similarly, Huckle's rule and all. Then we have different kinds of name reactions. So this is how we make reaction, name reaction ka one column, precursor, catalyst, intermediates, and the product. So your acetoacetic mein beta ketoester is a reactant. The catalyst is any alkyl halide or in the presence of a base, then it's forming beta ketoester as an intermediate, and the final product is substitute in esters or substituted astones. Similarly, aldol, canizaro. So this is how you need to make a table. It's from Amit Verma book. Please do have a look at the book for name reactions. So we have Sanyal, we have Bal and Bal. A lot of name reaction books. You can have a look at them for sure. And this kind of table you need to prepare. So that log bolte, because the people complain about this, that our name reactions are weak. We cannot complete name reactions. Make table. It will be completed in 2 days. You will learn all 68 name reactions in pharmacy field. So it's different kinds of bonding, sigma, pi, sandwich, dipole level interactions, thermodynamic techniques you need to know, solubility, K tables. There are so many different tables from physical pharmacy, microanalytics, rheology, complexation. You choose a particular subtopic, you can make a table. So आप कोई भी subtopic उठा लो आप उससे table बना दो. अगर आपकी if your one book is only of tables, you will revise that book 1 day, 1 month before exam. Then from pharmacology, you need to know the drug classification. Like suppose ibuprofen. So mechanism of action, it's a cyclooxygenase inhibitor. Uses inflammation, pain, rheumatoid arthritis, side effects. Then you need to know about the different, ring also. Like you can make one more column of ring. So if it's having alkanoic acid, propionic acid derivative, like this is example is ACE inhibitors. So mechanisms, uses, adverse effects, we need to know very well. And finally, this is a particular table that describes particular subject and the particular key topics. Pharmacology, physical pharmacy, jurisprudence, management, pseudix, engineering, pharmacokinetics, biotech, physical chemistry. So this table is very, very important. So you need to know the classification, micromatrix, rheology, solubility and all, pharmacy act and all. Management, you need to know what is Ansof's matrix, what are the different kinds of marketing, selling, what is the difference between them, what are promotional strategies, what is BCG matrix and all. Then you need to know what is STP, the 9 P's of marketing and all. You need to be aware about them. Pharmaceutics say different dosage forms for sure, including novel drug delivery system and implants and all those things. They are also being asked nowadays. Biopharmaceutics say obviously bioequivalence, pharmaceutical equivalence, therapeutic equivalence, pathophysiology say apoptosis, necrosis, all those things. Biochemistry say metabolic pathways, I already mentioned about them. Physical chemistry say you have phase equilibrium, phenol water. From also you can study about the phenol water coefficient, upper consulate temperature, lower consulate temperature, UCT, LCT. That is also previously being asked. And finally, organic chemistry, say name, reaction, functional groups, you need to know. So that's it for today's video. I hope these tables were informative to you. These 40 tables are being worth making, and these are just 40. You can make 400 tables if you choose the subtopic. So from micromagnetics alone, I can make fundamental properties per luck, derived properties per luck table, different types of diameters per luck table. From one subtopic, you can make 3-4 tables again. So these are the main tables that I mentioned, that from which questions do appear, and you will be seeing 15 to 20 questions as it is from these tables. So make sure you make them. So thank you so much for watching the video.